Let's look at one more example of how to simplify a complex fraction. So let's darken in our main fraction bar so we can see the separation between our numerator and our denominator. So in the numerator, we have 4 over x plus h. So the denominator is x plus h minus 4 over x. So we have another denominator of x. And since in the denominator of the overall complex fraction, all we have is h, we don't have a fraction, we only need to consider the two denominators from the expressions in the numerator for our LCD. So our LCD is formed by making the product of the denominator x times the denominator x plus h. So that is my LCD. So I'm going to multiply the numerator and denominator of my complex fraction by the LCD, which is x times x plus h. All right, in the numerator, I have to distribute. So when I distribute the LCD to the expression 4 over x plus h, the factor x plus h will cancel out or divide out. So I'm just left with the numerator 4 times x, but the fraction has been cleared. Minus, now I'm going to distribute again. When I distribute to the fraction 4 over x, the x is the common factor, so the x's will divide out, and I'm left with minus 4 times the other factor from the LCD, which is x plus h. Then I have my main fraction bar. Now, in the denominator, nothing cancels out. X gets multiplied by x times x plus h. I'm sorry, h gets multiplied by x times x plus h. All right, we need to do some distributing and simplifying in our numerator. So now we have 4x minus 4h over h times x plus h. Now you might be wondering why I'm not distributing the numerator. You might be wondering why I'm not distributing in the denominator. And it's because I want to leave my denominator in factored form, because after I combine like terms in the numerator, I might see some common factors that can be divided out. So in the numerator, I want to combine my x terms. So I'm left with negative 4h over hx times x plus h. And this is what I was just talking about. Now I see a common factor of h that can be divided out. So my final answer is simply negative 4 over x times x plus h. Now, quite often, students want to know, well, how do I check that? Like, how do I check that answer and find out if it's correct or not? Well, there is a way to definitely check your answer. So let me just briefly explain it to you, and then we can look at it more in depth in class. So it's kind of fun to check your answers for these. So you can choose any numbers you want to represent the variables. So what I mean by that is choose any number you want to represent h or x. Choose any number you want to represent x, whatever number you want. Let's say you want it to be 2. Okay, and then choose another number, again, any number you want to represent h. So let's say we let h equal negative 5. Again, it does not matter. I just wouldn't let them be the same numbers. I'd get some difference in numbers there. And then what you do is you go back into the original expression, and everywhere you see h, we will replace it with the number you chose, so negative 5. And then everywhere you see x, we'll replace it, in this case, with the number you chose, which might be 2. And then once you have numbers substituted in for all your variables, simplify the original complex fraction, and you can even just type it in on your calculator and get a numerical answer. It doesn't matter what the number is, but then also come down and do the same thing to your simplified final answer, plug in those same values for x and h, get a numerical answer, and as long as those numbers match, whether it's a fraction, a decimal, positive, negative, whatever, then you know your simplified answer is equivalent to the original expression, and you know you've simplified the complex fraction correctly.